All right, hey students, I'm going to go over the notes 4.2, and it's about perpendicular bisectors, Pythagorean theorem, and circumcenter. So to make these videos short, I'm going to break it down into 3 parts. So make sure you watch all 3 videos to go over all of these notes. So the first video, it's about discussing what perpendicular bisectors are and what theorems, what rules are there about them. The perpendicular bisector theorem states that if a point lies on the perpendicular bisector, notice that there's a 90-degree right there, so this is the perpendicular bisector. If there's a point on this line, then it is equidistant from the endpoints of the segment. So if I draw a point right here, that means that this to that endpoint is going to be congruent from this to that endpoint. Let me do 2 dashes so you don't get confused. This means any point. So if I look at any point, let me use a highlighter. If I select any point on that perpendicular bisector and I compare it to the endpoints, it creates an isosceles triangle. It creates these 2 side lengths equal. So that's what this is stating. The next part is converse of that. So now if you are told that these 2 side lengths are equal, then you are to assume that you could have a perpendicular bisector going through that vertex point up here. So imagine creating a line that is 90 degrees from this. And what's going to happen is that because it is perpendicular, we are to assume that these 2 side lengths are equal. That's what this is stating. All right, let's practice those theorems in the examples below. So number 1, it's already done for you to just explain to do like what are we doing. Based on the image, they're just giving you these side lengths right here, and you need to look at what's happening here. So they're giving you a line that's forming that 90 degree. So that is your perpendicular bisector, which means that it created the 90 degree, and it also created these 2 side lengths equal to each other because they're equidistant to the endpoints of this segment. Therefore, we write the equation of these 2 expressions equaling each other, and then we do the math to solve for x. We move the x's to one side, numbers to the other by adding and subtracting, and then we isolate the variable by dividing by the coefficient, and you get the answer. So let's try number 2. Let's look at what you're given. You have the the 90 degree angle formed right there. So you are to assume that this is your perpendicular bisector, and then apply what you know about it. So the perpendicular bisector means that these 2 are equal, but then remember that also means that these 2 side lengths are equal. So therefore, these 2 expressions are equal. So 17x minus 3 equals 9x plus 13. And we solve for x. So let's move the x's to one side, the numbers to another side. X's cancel here, numbers cancel here, and now we have 17 minus 9, which is 20, no, 6. It's 6. 6 and 9, sorry, it's late. It's 8, right? And then over here we have 13 plus 3, which is 16. So then now we divide by 8, and x equals 2. So that will be the answer for that one. On this one, you can pause the video anytime if you want to try this on your own, and then press play to check that you did it right. Here's the 90 degree, which means that this line right here, let me just highlight the line. Those are your perpendicular bisectors, which means that these 2 side lengths are equal. And we're going to write 7x minus 22 equals 4x plus 5. And we solve, moving the x's to one side, moving the numbers to the other. So we have 3x equals 27. And divided by 3, so x equals 9. Now here, compared to these two up here, this one's asking you to find RS. So now you're going to look at what RS is. RS is this part, which means this expression. So we're going to solve RS by doing 4 times 9 plus 5, because it's 4x plus 5. 4 times 9 is 36. 36 plus 5, it equals 41. So RS is 41. All right, let's try the next one. We have EG. So we're going to be finding what nope, not that one, sorry. I'll just highlight these two as equal. And then I'll hide EG. That way we know that's the one we're solving. So perpendicular bisector, 90 degrees right there. This is a perpendicular bisector. And that means that these two side lengths are equal, which means that these two sides are equal. Then we compare them to each other. So we have 2x plus 11 equals 14x minus 37. And we solve by moving the x's to one side, moving the numbers to the other. So 2x minus 14x is negative 12x, and negative 37 minus 11 is negative 48. Divide by negative 12, and x equals positive 4. It's asking for EG, so now we're going to use that value in that expression, EG. So 2 times 4 plus 11, that's 8 plus 11, which is 19. So EG is 19. On the next, we have find AB. I'm gonna highlight it yellow. AB, all the way, this and that together. We are going to identify that there's a perpendicular bisector right here. And therefore, this means that besides these being equal, also these are equal. So we're going to have 5x minus 11 equals 3x plus 17. And that means we're going to move the x's to one side, move the numbers to the other. And that's 2x equals 28. And now we divide that by 2. So x equals 14. Now this one's asking for AB, which requires you to combine these two expressions. I'm going to find one of them, because if we find one, then we know the other because they're equal. So just pick an expression and substitute the value and double it. So 5 times 14 minus 11. 5 times 14, I need that calculation, sorry. So 5 times 14, that is 70. So 70 minus 11, that results in 59. Yep, 59. So this side length is 59, and because it's equal, we're going to say 59 right there too. So we can just do 2 times 59, or 59 plus 59, and that results in 118. That is the measure for AB. All right, let's try JK over here, perpendicular bisector right there. They want you to find JK. JK is this side. So we know that these two are congruent because of a perpendicular bisector. So 6x minus 26 equals 3x plus 34 minus 3x minus 3x plus 26 plus 26. So 3x equals 60. Divide by 3, x equals 20. JK is this expression right here. So we're going to do 6 times 20 minus 26, and that's 120 minus 26, which equals 94. So that's the measure of JK. All right, last problem for this video. It's giving you now without pictures, so biggest advice is create your own picture. And let's see, JK is formed by these 2 points. Determine if L lies on the perpendicular bisector of JK. So let's make a visual for that. So let's say JK is graphed somewhere on the grid, plotting these points. And then you need to check if you have a point L lying on the perpendicular bisector, which means that you're going to have a line crossing at 90 degrees, and you're asking if a point on this labeled L is that perpendicular bisector or lies on the perpendicular bisector. So for this to be a yes as an answer, you need to find the distance from here to here, from J to L, and then find the distance from here to here, from L to K, and they should be equal because a perpendicular bisector creates 2 equidistant segments to the endpoints. So now let's look at setting that up. We're going to do the distance formula again. X minus x squared plus y minus y. And we're going to do these 2 to compare and see if they're equal. So let's see. We have JL, J to L. And that's going to be square root of -7 minus -9 squared plus -8 minus 2 squared. Okay, and then the other one will be LK, and that will be -9 minus 1 squared plus 2 minus 4 squared. And if this is going to be a yes, we have to have the same answer right here. So let's check that on our calculator. Square root of -7 minus -9 squared plus -8 minus 2 squared. All right, let's check what the other one is. We have -9 minus 1 squared plus 2 minus 4 squared. And these do result in the same answer, 10.198, 10.198. So we're going to say yes. We're going to say yes, point L is part of the points in the perpendicular bisector. All right, hope this video helps you.